All right, question number 3. We're going to state the value of lambda and t for this Poisson process. So this one says the flaws in a piece of timber occur at a rate of 0.07 per linear foot. So this is our rate. This will tell us our lambda, 0.07 per linear foot. And then it goes on, it says the random variable x is the number of flaws in the next 15 linear feet. So you get 0.07 per foot, and then it's telling you we're doing 15 feet. So that is my interval that we're doing this over. So there's 15 intervals. That would be our t. All right, so once you identify your lambda and your t, you will usually multiply these together, and that will give you your mean. So this is one of the things we saw. Lambda times t, that's the parameter, that is equal to our mean. And that's the one that we use for the Poisson process. So you need your mean and you need number of successes that you're trying to solve for. So this one has 4 parts. We're going to find the probability of the Poisson process. So it says assume that the mean is 6. So they're saying that we already got the lambda, we already got the t, we've multiplied them together. We're getting a mean of 6, and we're going to compute the following. So if you have a mean of 6, what's the probability that you have 6 success, less than 6 success, greater than or equal to 6, or between 5 and 8? Now, to answer these, we're going to use StatCrunch. I'm going to go ahead and use the StatCrunch system. So you open up StatCrunch. I'm going to move this over a little bit. We're going to go to Stat, Calculators, go over, and then you're going to look for the Poisson down here, right below normal. Right now we're going to start on standard. It's already on standard. If I do between, that will give me like between 2, like when I get to D. So we're going to start on standard, tell it we need a mean of 6, and we want equal to 6. So you're going to come down here, change this to equal to, and we're going to change this to 6. Okay. So you're just going to put in the parameters. Put in the parameters, make sure you choose the correct computation. I can't even see, this is in the way. There we go. All right, so the probability of getting 6 successes when the mean is 6 is 0.1606, and we want to round to 4 decimal places, and that will not round. 0.1606. Okay, so while I have this open, I'm now going to do less than 6. Less than. So just change that. You still got the mean of 6. We're just going to change that to less than. And as you do it, it automatically computes, but you can kind of see it there. So less than 6 would include 5, 4, 3, 2, 1, or 0. It adds all those up for you, and it gives you 0.4457 when rounded. C, probability of x is greater than or equal to 6. Greater than or equal to 6. So we're just going to change that to greater than or equal to. So that would mean 6 or more. So 6, 7, 8, 9, 10, 11, all the way to infinity. That seems like it would be hard to compute, but there are some probability properties that says if you add everything up, it equals to 1. And if you do 1 minus, again, what we got in the previous problem. So let me just show you that. So if I can compute 0 up to some point, I can compute that point up to infinity. So remember, total probability, probability of x is equal to, you know, that might be P1, P2, P3, dot, 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 so on. When you add up everything possible, you get 1. Well, if you subtract those parts, so if you take 1, the total probability, and subtract everything less, So when we said probability that x is less than 6, that was 5, 4, 3, 2, 1, we got 1 minus point. The previous problem was 4, 4, 5, 7. So if you do 1 minus 0.4457, that will give you 0.5, 5, 4, 3. And that's the same answer that we should be getting here. Let me make sure I did that math correctly. Calculator. And we're going to do 1 minus 0.4457. And we get 0.5543. And that, I also believe, is what we're getting on the Stack Crunch window, 0.5543. So that's kind of where that's coming from. So if you're wondering, like, how do you compute from 6 and beyond? Because it's 6, 7, 8, 9, 10, 11, 12. It could be any number, 100, 1,000, all the way to infinity. You just use a little algebra to kind of rewrite or reorder that problem. So we get 0.5543 for greater than 6. And then if we want to know between two numbers, we would change this to between, and we want to know between 5 and 8. So I'll know between 5 and 8. And it gives me 0.5622 when rounded.